In this module, we are going to show that if we know the vector v and I, j, k are mutually orthogonal, we can extract vx, vy, and vz using the dot product like this. So we have v. I'm going to do a dot product with the I like this. So v is vx in the I direction plus vy in the j direction plus vz in the k direction, and the whole thing is dotted with the I. What I can do here is I will distribute I to every term inside the bracket. So the first one is going to be this vi dot I plus the second term vyj dot I plus the last term vzk dot I. Remember that when we have a dot product between two vectors, it's going to be the magnitude of the first vector, the magnitude of the second vector, and cosine of angle between these two vectors. So we are going to do it here. The first vector has a magnitude of vx. The second vector has a magnitude of 1 because it's a unit vector. And cosine of angle between vector I and vector I itself. Now vector I, let's say, is this direction. The vector I itself will have an angle of 0 degrees with respect to itself, right? We're going to the next term. This one has a magnitude of vy. I itself has a magnitude of 1. And the cosine of angle. Now, I and j are orthogonal. So I is here, j is orthogonal, which means that their angle is 90 degrees. Plus the last one, this magnitude is vz, this magnitude is 1, and cosine of angle. Again, I and k are orthogonal, their angle is 90 degrees. So this term goes to 0 because cosine 90 is 0. So is this term. Cosine of 0 is 1. So we are left with vx only. There you go. We have shown that vx is equal to the vector v dot the unit vector I. Before moving on, let's try to show this one as well. We are doing the same thing. We are going to dot product the unit vector j to the vector v. So writing out vector v with vxi, vyj, and vzk, and everything is dotted by a vector j. First term is vxi dot with j plus the second term vyj dot with j and vzk dotted with j. And using the dot product formula, we have the magnitude for this one is vx. The magnitude for j is 1 because it's the unit vector. Now a cosine of angle between I and j is 90 because it's orthogonal. Now the second term is this magnitude is vy. The magnitude of j is 1. And the angle between j and j is 0. Now, last term, this magnitude is vz. This magnitude is 1. And angle between k and j is 90 degrees. because they are orthogonal. Cosine 90 is 0, cosine 90 is 0, cosine 0 is 1. So you are only left with Vy. There you go again. Vy can be calculated from a dot product between V and the unit vector j. So we have shown this one, we have shown this one. You can prove yourself this one as well. In conclusion, when we have orthogonal decomposition, it allows you to write the vector in terms of the orthogonal components in the, let's say, I, j, and k axes. And if you know the vector v, you can retrieve vx, vy, vz using this set of formulas. In the next few videos, we are going to practice two things. First, we are going to try to decompose a given vector to its component. And second, we're going to try to build a vector from its given components. To enforce your learning, write, comment, or share what you have learned today and hashtag PhysicsLitUp. And subscribe to Physics Lit Up for the next video.